Hi again, welcome back to Chapter 5. In this video, we will work a series of annuity problems when one of the variables is missing. We'll start out with a present value of an ordinary annuity calculation. Assume that you borrow $700 from a friend and intend to repay the amount in 4 equal installments beginning 1 year from today. Your friend wishes to be reimbursed for the time value of money at an 8% annual rate. What is the required annual payment that must be made? In other words, what is the annuity amount to repay the loan in 4 years? We know that n equals 4. We know that I equals 8. We know that the present value is 700. And we know that the payments are to be made at the end of the compounding period, so this is a present value of an ordinary annuity calculation, and we will use Table 4. What we don't know is the payment amount. Step 1. Let's catch the slide up with us first. Step 1, find the applicable factor on Table 4, where n equals 4 and I equals 8. So turning to Table 4, present value of an ordinary annuity, n equals 4, I equals 8%, and the factor is 3.31213. Step 2, divide the present value by that factor. And you get payments of $211.34. So the required annual payment is $211.34. Let's look at another problem. Assume that you borrow $700 from a friend and intend to repay the amount in equal installments of $100 per year over a period of years. The payments will be made at the end of the year beginning 1 year from today. Your friend wishes a return of 7% annual rate. How many years would it take before you repay the loan? Let's determine what pieces we know and what factor or piece is missing. We don't know n. We don't know how many numbers of payments. We do know that I equals 7%. We know that the present value is $700. We know that payments are made at the end of the compounding period, so this is a present value of an ordinary annuity calculation. We will use Table 4 again. Step 1. Divide the present value by the payment amount. 700 divided by 100 equals 7. Now this 7 it's a coincidence that this 7 is the same number as the percentage, as what the value of I. That's totally a coincidence, and don't get them confused. 700 divided $100 payment amount equals 7. And what we want to do is take a look at Table 4 and read the 7% column down until you see a factor close to 7. Table 4, 7% column read down. The factor closest to 7 is 7.02358. Read this row over to the left to see that 10 periods is the closest. Therefore, it will take approximately 10 years to pay off the loan. Let's look at another problem. Suppose a friend asks to borrow $331 today and promise to repay you $100 at the end of each year for the next 4 years. What is the annual interest rate implicit in this agreement? Let's determine what we know and figure out what piece is missing. We know that n equals 4. We know that the present value is $331. We know the annuity amount is $100. We know that the payments are made at the end of the compounding period, so this is a present value of an ordinary annuity problem, Table 4 again. What we don't know is what the interest rate is. Step 1. Divide the present value by the annuity amount. 331 divided by 100 equals 3.31. Step 2. Look at Table 4 and follow n equals 4, that row across, until you spot a factor close to this. Table 4, n equals 4, reading across, looking for something close to 3.31. 3.31. Here it is. 3.31 is under the 8% column. So the effective interest rate is just about 8%. Let's work another problem that's just a little bit more complicated. Suppose you borrowed $400 from a friend and promised to repay the loan by making 3 annual payments of $100 each at the end of the next 3 years, plus a final payment of $200 at the end of year 4. What is the interest rate implicit in this agreement? Let's determine what we know and which piece is missing. N. Well, there are 2 periods. We have the annuity period of 3 years, and we have the lump sum of $200 being made 4 years later. That's not an annuity, that's a lump sum. So we've got 2 periods, n equals 3 and n equals 4. We don't know the interest rate. We do know that the present value is $400. We do know that the annuity amount equals $100, where n equals 3. We're going to use the present value of an ordinary annuity table, Table 4. We also know that the lump sum payment is $200, where n equals 4, and we want to find the present value of that at an interest rate using Table 2. And the payments of the annuity are made at the end of the compounding period, so this is a present value of an annuity calculation, Table 4. So we will be using both Table 4 and Table 2. So what we're going to do to solve this problem is to find the present value of the annuity and add it to the present value of the lump sum payment. But we can't find a factor on the annuity tables because we don't know the interest rate. So we're going to work on a trial and error basis. Let's try an interest rate of 9% and see if the calculated present value is close to our present value of $400. So the present value of an ordinary annuity of $100, where n equals 3 and I equals 9, equals the $100 times the factor on the annuity table plus $200, the present value of $200, where n equals 4 and I equals 9. So let me show you those on the table. On the tables. Present value of an ordinary annuity, where n equals 3. There are 3 annuity payments. And we're guessing that I might be somewhere around 9%. So we'll go over and take a look at 9. And the factor is 2.53129. Multiply that factor times the $100 annuity amount, and you calculate $253. Then turn to the present value table, table 2, and we want to find the present value of $200, where n equals 4, and we're guessing 9%. So read it over, and the factor is 0.70843. Multiply that times $200, and that equals 142. If you add $253, the present value of the ordinary annuity amount, plus $142, the present value of $200, you will get $395. That's really close to our present value amount. It's a little under our present value amount. So we know the interest rate's probably going to be somewhere around 9%. Let's see if we can bracket it a little bit and get a closer amount, closer interest amount. So let's try the whole problem again at 8%. Run these same calculations through, only use an 8% interest rate. And when you do that, you will calculate a present value of $405. So we've just bracketed our present value, and we know that the implicit interest rate is somewhere between 8 and 9%. The Oh My Gosh Company purchased office furniture for $25,800 and agreed to pay for the purchase by making 5 annual installment payments beginning 1 year from today. The installment payments include interest at 8%. The present value of an ordinary annuity for 5 periods at 8% is 3.99271. And the present value of an annuity due for 5 periods at 8% is 4.31213. What is the required annual installment? Well, you're going to have to decide whether it's an ordinary annuity or an annuity due, and you're going to have to remember that it's not a multiplication problem. If you wanted to find what the payment would be without any interest, you would divide $25,800 by 5. So once you get your factor, you're not going to multiply anything. Go ahead and do your calculation, select your answer.